Well, appreciate the invite today. It's an interesting topic. This is our topic today that TriStar would like to really share with your organization are some of the challenges and potentially when you're looking at your longer term PLM maturity, the impact and really the value of coming off family tables. It's always been a challenge, I know, for many organizations about how they manage them and what's their real value in light of really the changes that have happened over the past really 25 years with really the systems that we now have available to tie all the data together. So for today, I'm trying to, there we go. I'll give you a quick introduction to TriStar and myself. It'll only take about a minute. Then we're going to talk about PLM organizational maturity model. And this is TriStar's view of really how businesses can gauge where they are in terms of achieving ultimately what we call the enterprise PLM. Where then we'll talk about drawing centric versus part centric, and there's a reason that we need to talk about that because there is an impact from family tables involved with that, the change management impacts, and then we'll specifically look at family tables, typically what's being done today, and then we'll take you through a technology that we represent that will potentially give you some options, better options, we believe, in terms of addressing what you were trying to achieve with family tables. And then we'll do a summary and do questions. So kickoff, TriStar was founded in 1988. We're based out of Phoenix, Arizona. Most of us from the organization that work with customers typically are out, and we work from our local locations. So I'm working here in Madison, Wisconsin. My name is David Cutter. I am a senior solution architect with TriStar. I've been with them now for 2 years. My expertise is more on actual process, configuration management, change management. I am a CM2 certified expert. And so what TriStar has started to do is bring resources like myself into the company so that we can work closer with companies such as yourselves, not so much necessarily strictly on the technology aspect, but also the strategies and the impacts that your processes have that we want to ultimately model in Windchill across your organization. So that's really what we're really focused on. We have over 5,000 customers we deal with globally. So when we look at PLM, the organizational maturity, a lot of people always are curious, what is PLM? And so what we at TriStar have done is we've developed what we call our maturity model. And that maturity model looks at really where, when we do assessments of customers and look at what their processes are and the controls they have in place and some of the integration aspects, we then can establish really where they are in this maturity. And so when we start off, you've got, potentially really ad hoc data management. So you got your Windows files, network locations, hard documents, those types of things, and you're trying to manage all of that to manage the data on your product. Now, that adds, that has a number of impacts to your organization. A lot of it negative because it's typically highly manual. You need a lot of tribal knowledge. You need just the way to get the data to people is very difficult. So then you can progress to the next level where you have a CAD data management level. So you're typically, that would have been like your Pro Intralink in the past with Creo. And then that's managing those objects, their relationships for the design side. Okay, so but the thing about it is it's still disconnected from other groups that actually need data from the actual CAD. And so while your CAD can be under control, you still have, as an organization, challenges about how you communicate out to your organization the requirements and the specifications they have to meet to be able to produce it. Next level is PDM, product data management. Now in this one, we look at this. So if you've purchased Windchill, if you're running Windchill and you're doing many different engineering disciplines are being managed within that, you can have some rudimentary change management, most likely departmental based. So those things are still more focused on really the engineering side, but not necessarily engaging some of the other processes that the business has to be able to produce and actually generate revenue. So then you come into what we call the first tier of PLM, which is now you can have, if you've achieved this level, you've got multidiscipline BoMs in a single system. You have that part-centric cross-functional. And the big piece here is you're getting that enterprise change management, your ERP integrations, and you get your PLM-enabled configuration management so you can do your baselines and such, effectivity and traceability throughout the organization. And then finally, at the very, what we call the full enterprise PLM, this is where really there is no distinction in reality between whether you're looking at Windchill and the, let's say your ERP. They function together, and all the processes, all of the elements that interact to be able to produce, support, and sell your product are really harmonized in a single process environment, whether or not the data is over in Windchill from the authoring perspective or the production aspects in your ERP. When you look at it, everything, when you want to make a change, is going across the whole thing. So that's the big push that typically most companies want to get to eventually. Then we have what we call a business transformation model. I'm not going to spend much time, but basically it just has some definitions that say typically, these are the steps you have to go through to achieve that level of definition for where you're going or where you're at. All right, so now we're looking at drawing centric versus part centric. I don't know how many of you have heard this term, but if we look at history, everything started off before there was computers and technology. We started off on paper. And through that, processes were developed that enabled, as best as possible, the communication using that paper to the organizations to be able to make and support their product. But as time has gone on, there have been improvements in terms of how relationships can be established and where the information really should be managed and communicated from. And so that's where, when we look at things like Creo and Windchill, they provide digital information. They can provide relationships between the various objects. And so when we look at it, to be able to really have good foundational BoM management, we need to move from that drawing-centric to a part-centric approach to things. And so when we look at what are the prerequisites to really establish that, we have really what's in Windchill called the WT document definition. What are those? Full WT part data modeling. Now, some of the terminology here, when we say a part, this is going to be the interesting thing, because if you ask a designer, a part is an object that Creo is doing. But if you ask somebody from the business side or really configuration management, the part is a Windchill object. So when we look at moving forward, really the Windchill part object is the object that provides the knowledge and communicates out to the organization the maturity of the design of that part and all of the relevant specifications and procedures and other data that's necessary for the business to be able to produce and support that part. So you got to look at movement of specifications like material and function and all of that off of the drawing, because right now in a drawing centric, if you have a drawing centric environment, that data is on the drawing, and a lot of times, and we're still dealing with companies today that when we engage them, they're like, well, our shop floor gets everything they need from the drawing. But that has ramifications and a lot of negative impacts to how efficiently they can produce their product. So you want to do an analysis and also an elimination of tabled specifications, i.e. family tables. So some of the post-requisites, okay, after this is your new product introduction and release process needs to be re-architectured if you're using the drawing-centric approach. And then you need to identify really the required validators in your process so that when you're going through and doing change and adjustments to the product, these are the things that will check things. So why is part-centric really worth it? It's a discipline and it has effort, and that's required to manually perform best practices of CM2. Well, the thing about it is with CM2 is not a technology, it is a methodology for how you structure, configure your relationship of the documents and your parts and how that all ties and how you manage the change to it. So you're applying that on your part-centric approach. You have a high degree of enterprise collaboration earlier in the process. And by what we mean by that is traditionally, your downstream organization really was waiting for a drawing. And then once they saw the drawing, then they could come back to engineering with any, quote, input or adjustments to that. And then engineering would go back and, if they agreed to the adjustments, they would have to go through and re-release those documents, the drawings, so that manufacturing understood what they were getting and they can produce the product. Now with a part-centric approach and with systems like Windchill, you can engage in your design process some of those other functional groups to gain input before you release the data. Because as soon as you release the data, there's a higher cost to go back and change it. Whereas if you haven't released it yet, the change is really a lot less, because really you're only dealing, and I say figuratively, only dealing with engineering time. But when you think about the cost, once you release it, of engaging those other resources, and they go off and start doing things with that data and specifications, then they're buying things and they're trying out, they're trying to build the product. They find things don't really go together the way that they're supposed to. You end up with, non-conformance. You end up with to what the design intent was. You get scrap, and then you got to go back through and redo it all again. So a lot of effort there. And so it allows for significant risk reduction the sooner you can get more people up front. And that in turn reduces your downstream, improves your impact change analysis, because now with a system like Windchill, you say, I want to make a change, you can now see all of the objects, whether they are parts, CAD documents, or documents, non-CAD documents. You can see everything that gets impacted for the change. And therefore, you can turn around and shorten time, because now you've identified everything up front, instead of, well, we start here, and then once we release it here, then they'll make a determination of what they've got to do, and so forth. So it really does allow for faster process. And when we look at the part-centric behavior, you're looking at being able to have automated governance. So that's what Windchill brings to it. So you can have system control versus human intervention. You do have the intervention at the very beginning, but as it's going through the process, the system is helping control the flow, what's applicable based on your business, and so forth. So what you get here in benefit is just low touch processes. You have immediate impact analysis, and you can reduce your risk by significantly, because you're doing it at a time when you haven't invested in tooling and lots of other activities in your organization. So when we look at trying to set it up and get to being a part-centric, you're going to have to go through a data cleansing effort in most cases. You want to have elimination of table specification practices. You want to have a new part development versus developing the drawing mentality. Document typing and watermarking, you may have requirements for those. Part typing, we can have different part types within Windchill, subtypes as we call them. And they in turn can have all their own attributes and other documents that are specifically tied to them. You can then look at classification, especially if you're doing electronics, supplier collaboration process. The big thing here is that once you achieve this, you have the ability then to fully have a defined, integrated, system-governed EBOM. When you have document-centric, you can't really achieve that. So, problems with the BoM on the drawing. Well, in reality, whoever you're giving the drawing to thinks that that is the truth. Okay, but in Windchill, the drawing isn't the truth, it's the part that's the truth. So making sure that how we communicate in an organization about the truth is paramount. You can't integrate a drawing to an ERP system. The only thing, excuse me, that really can do that integration, excuse me, is the WT part. And that's what communicates its identity. It's what communicates, here's attribution, here's the various specification IDs and so forth that the ERP side can utilize. Organizations will still use the drawing as location to collect all the specs and additional information instead of getting the actual specification documents that they need to have. So if it's on the drawing, they think that that's all of them, and it may not be, and they may not be correct, because you'll see in a slide following how things can get out of sync. Manually perform to get it into the ERP. It's the only way you can do it if you're drawing based. Cannot effectively communicate or manage effectivity on a drawing. Okay, so you can't turn around and have the system provide you with the view of when this was effective in manufacturing. Cannot improve long lead time item processes. It's hard. You got a lot of extra effort to go in to do that. I'm just going to blow through some of these. And the big thing here is that a drawing release is not a part release. In Windchill, to be able to achieve the part release, the drawing has to go to release at either at the same time or already be completed. But it's the part that's important, because it will have the drawing, it will have all of the other specifications, and it communicates through its attribution where that maturity level is for the part. All right, so when we look at it today, if you're looking at really a drawing approach, drawing centric, you'll have your CAD structure that's going to be sitting over here in Windchill. And you're going to have a manual process that basically has to look at a drawing, you know, the output, the visual output of this into a list that has to be interpreted, that then turns around and has to be manually input into your ERP. And through this whole cycle is time and the introduction of potential defects. So mistypes, those types of things happen. And so this process here is not the most efficient once you have a system like Windchill. And when you move and start doing a part BoM, okay, so you'll see here the symbols are showing the gear, which is the WT part. They have associated CAD, no doubt, and very important. But this is what ends up getting and being able to be communicated through an automated push when a CN is used to do a release, that we can push that data straight into the ERP automatically. So, you know, I've seen releases that have 8,000 parts on them, a number of sub-assemblies, and then you know, obviously the end product, and that can be all sent over to the ERP in less than 3 minutes and set up. I would hazard to guess it takes considerably longer if you're doing your upper process. So what are the change impacts to this? Well, you got to have your single source of truth. And again, I'm just going to accelerate through this portion. But when you're looking at the documentation is primary intent, non-design data is kept separate from design data. The drawing is not a collection space for enterprise part data. And enterprise part data is material specifications, process specs, performance specs. A single document represents a single design, not tabulated and not charted. There should be a specific representation for the specific part. Because all of this information, we've seen even more. We've seen actually routings and all kinds of information on the drawing that the engineering is having to maintain. And most of the time, it goes obsolete very quickly and causes them problems. So, you know, when you're looking at like a tabled drawing, like this is to be representing here, in reality, there should be a drawing for each one because each one of these is a different part number. So in our part-centric focus, really processes manage the documents. The documents describe the parts. The items aren't the focus, it's the document collection, okay, to the part. And that's a CM2 piece. The part is, it's sort of funny how everybody sort of says how important the part is. Its importance is two things. One, to communicate the maturity. Two, to communicate and provide all of the required documents at the appropriate rev to be able to produce and have that part perform to what engineering has defined. Okay. So we move away from that drawing centric to a part centric because it's that part that does it, not the drawing. It's the part that can do this. And then when you're looking at your closed loop processes, you have basically the objects that allow you to manage that change. And this is following predominantly the CM2 process here, where you may have issues that arise. You're going to write ECRs to change them and ECNs to implement what the change is. And then as they finish, it closes out. So if we're looking at a drawing specific, we got a material spec, and that material spec is being held on the drawing. And everything seems to be copacetic, and there's a performance spec, and that's being communicated in the notes on the drawing for that part. So that part, you know, they went and decided to make a material change on that material spec, okay, which is used on this part. And when they got implemented, it reduced the cost of this part because they made a change that required less material, let's say. So now, but that material spec was also used on all these other parts. So you assume, you know, somebody who was looking at that originally may not have really understood the fact that these are also using it, but they think they're going to get again the benefit. The problem is they have a different performance spec, and that performance spec requires the material when it was at A, not at B. So what ends up happening is, because the information is on the drawing, you have to go back, and you would have to make sure you created a new material spec instead of revving it and put that in the drawing note. Otherwise, you're going to end up with rework warranty defects, because over here, these parts are failing because of that material spec change. Okay, so you didn't get any benefit, you went the reverse way. This is a busy slide. I'm not going to spend a lot of time on it, but this is basically our view of a data relationship, part relationship, all the way from design, all the way over to manufacturing, including the process plans and everything. Everything is interrelated. Whether you're using Windchill to do all of this portion, or you're splitting it at some place either in here or here with the ERP, but you can pass all this information to the ERP. And it's all of this is what you're dealing with every day as an organization. Engineering, yes, maybe only up here, but it has an impact to everything downstream. And that's the piece people really don't take into account when they're thinking about all these various things. So when you're looking at the role of PLM, this is where you want all your activity, because you want your transactional side, your ERP and your your manufacturing execution systems, they need to be pretty static because their volume. Everything else is happening over here and should be managed over here, because that's providing the data that this system utilizes. Okay. Family tables, how they're managed today. So today we have, here's a typical table drawing, and this is the what I'm showing here actually is that every single one of these is a part. It's a physical part. Every one of those is a different part number. So how can one drawing really represent a whole bunch of parts, especially when we're looking at a potential change? It could be an addition to the chart, or it could be that something had to change on it because let's say in this one they need to make a slight adjustment to it. So you have to go through and take it, do your Rev B, and you've now updated the drawing, okay? And the part got revved, but all these other ones are still on this drawing. And what are you going to do? What do you do today with your current, the revs of all those other objects? Because, a lot of you would find, depending on what your approach is, you are having to check out everything, do your update to the table, and then check it all back in. And how often does that go? And you're being impacted by other assemblies, people have things checked out themselves. It really becomes a real coordination, a sync activity to try and get everything in sync if you're trying to keep these respective of every time this gets updated, these have to be updated. So we believe we have a tool that can provide really a way for you to achieve that bigger, longer term PLM part-centric approach, which we call RuleSoft. We represent that product. And what is it? It's a rapid development environment, and it can be linked to Creo, Creo View, SolidWorks, AutoCAD, and some other CAD tools. And it has a web interface. And then, but also it can be linked to Windchill through web services. And so when we look at this tool, it allows for a much, let's say, a more elegant approach to the family. One of the aspects is the family table. This also does configuration and a few other capabilities. But when we're looking at family table aspects, it gives a much more eloquent approach that reduces the amount of effort on your side and keeps it fast and reliable. So when we're looking at the challenges in Windchill, they can get big. So you get issues with performance in the system, downloading, updating, working with assemblies. So we have it has a tool. It's got many tools, but this particular tool is called the Parts Cleanser. And this converts family tables to standalone parts or inherited models. And so when you look at this, it manages logic within RuleSoft. The parts themselves are still within Windchill, but the rule logic is over in RuleSoft. So the benefits you get is a number of the dependents downloaded to your workspace are a lot less. You get faster performance, and you minimize unintentional family table instance modification. And I'm sure everybody's had to go through that, and the CAD admins are really happy when that happens. And then you got utilized configuration efficient inheritance for on features. So you have an interface here that lets you handle taking a top and making it basically independent parts versus what's considered a family table. So the family table is stripped into individual instances. They can also, or they can be converted to inheritance models, but only with Creo. It won't do that with the other CAD tools. It will do the individual instances, but it won't do that part. And the table basically is managed in RuleSoft. It's handling all of that aspect. So when you look at it, you'll see here we're going to have an activity where we're going to have a scenario 1 where the family table is going to go to standalone parts. All right, so the family table part is a standard purchased item, let's say like a bolt, like bolts or washers or capacitor or whatever that are typically historically been on table drawings. And typically a library is used for those types of parts as an example. And family tables will be stripped into the individual instances. Gregory, do you realize you're writing on the screen? Scenario 2, family table to inheritance models. Again, you can do that inheritance piece, and then all of this ends up, the logic is managed in RuleSoft, not in Windchill. And so you have what's called the design table. Now the product is actually being updated as I speak, and they're enhancing the design table portion. So when we look at how does this work, here's some screenshots. I don't have a live demo of this because I only just got it installed myself. But basically you're in Creo and you're looking at the table, your family table for that part. And so when we're looking to do this to standalone, you would see right now when you bring it into your workspace, you've got basically the generic with all of the instances. So what you do is you bring in your generic, and you'll see here there's a generic, and they're going to select strip instances out of the family tables. And what you'll see as a piece here, it'll come up and say, okay, this generic has all these parts, and it'll give you the count. You can confirm all that. And once you go through and process, then what comes out is you have the individual parts that will show up in the workspace. And so they will also have the ID that was on their instance. Once that has been completed, then over here you would see, okay, I've got, here's my generic, and nothing underneath it anymore. Now, when we do the inheritance approach, basically it's the same one again. We're rerunning this, but this time, and you'll see there's all the parts. This time we're going to actually select inheritance, convert to an inheritance part or model. And over here again, you get the count. Once you go through hit the button, then it comes back. It looks still the same with all these individual objects. However, now when you go to the objects, you will see, let me bring one more right here. When you open up that individual, you will see over here, it's got an external inheritance. So it does all this automatically. So depending on what your needs are, you can take existing tables and convert them. So in summary, for PLM maturity levels, every company needs to understand where they're at and where they want to go, because the big one here is it identifies processes and that may need to be alignment, and part of that is things like family tables. And when we look at the part-centric philosophy, again, we need to look at family tables. And so, when you look at the tool, and everybody complains about family tables, they always have. We believe this is a tool that we can bring to you and allow you to get yourselves prepared for the larger world of a more inclusive PLM environment following a part-centric approach. That will allow you much more flexibility in your design time and when you're doing your changes. And you can then turn around and look at some of the other capabilities that product has, specifically around configuration, if your company is wanting to look at potentially the ability to configure various combinations of views of your product to given features and so forth. So that's what I had for today. And if you want, I know we may have some questions. I've given, I think, about 13 minutes of time to answer questions. Also, if you want more information, and if you're interested in seeing the actual RuleSoft tool in a demo, please reach out to Devin. His email is here on the screen, and he'll be happy to arrange that for you. So, do we have questions?
There are some comments on the chat if you want to click on that.
Let's see, where? Chat 13.
Dave, I've been kind of answering them as they come in to my best abilities, but there's a few that I haven't been able to answer here.
All right, let's see. Where? Okay. Replace family table in this approach, for instance, used to drive consistency between features and models that are not varied. That's, again, that might be, but when you're looking at your part-centric approach, what's the value of the rest of your process against trying to retain the table approach for some of that other information. Exists an automatic option to export BoM from Windchill to ERP systems. That's not done through RuleSoft, that's done through Windchill. But yes, from Windchill to an ERP, there are interfaces that allow that automation. Let's see, if a W2 part has multiple described by relationships, that is the revision scheme. Documents must have independent revisions from each other, and they also bump when they revise. Depends on the document type. If it's a described by or the CAD object, or the model object, typically the part rev and those documents rev at the same time. But there are other documents, reference documents, that can rev independently of the actual parts. So you get, depending on what you're labeling it as, that will control whether or not you have to do both the part and the document. Okay, yeah, this is not in Windchill. This is a technology that is cloud-based. It sits outside. It interfaces with Windchill and handles all of the logic aspects. The logic is not in Windchill. So you are correct, Juan, that that it's outside Windchill. Leave APIs website. So technically it can be set up on Windchill. Yes, that is correct, Devin. You've answered that one. In your demo, if the generic and other parts are released, how could you make independent instances without having to revise all the other components? All right, so if you strip them out, they would come out with the revision that they were in the drawing. So we've got to remember, the drawing is a totally independent object from the part. So when you looked at those parts that were on, that I was reflecting or showing in the demo or in the slide presentation, they already had their own rev anyway, which the drawing was not showing, right? There wasn't any information. The rev that's on that drawing is the drawing of the rev of that particular document, not the parts. So you don't have to revise all the other components. If you do the strip out, they are what they are. You no longer use that drawing. Yes, is RuleSoft its own database? It has its own database. I believe it's based on SQL Server. I would like to get a couple of examples why FT should never be used. That, again, is really the question back is, with the part-centric approach, you really can't achieve what you're really after in terms of utilizing family tables. And the value of continuing to use them, I believe, is far outweighed by the value you get by not using family tables, because you will gain so much more in your efficiencies and getting the documents utilization better to your downstream folks. What are some of the reasons why family tables should not be used? We use them many times and they're very powerful. Yeah, we know, but that's, again, there's overhead for that. If I convert all instances to their own standalone parts, we don't have them lose the functionality of the family table with regards to interchangeability. what is the upside of doing that? Well, in reality, whether they're on a family table or not, that particular instance, you still have fit, form, and function issue. It's still another part. So there is, I don't see the quote, the functionality of interchangeability on a table drawing, because they aren't interchangeable. Every one of those parts is different. And if you're making an adjustment to just one of them, you still have to go through your fit, form, and function. And does that mean then that you're going to revise an existing instance, or are you going to create another instance because the fit, form, and function isn't maintained, and therefore, again, what's the value of a family table? It's still another part. It's still a part number that's sitting in Windchill and in your ERP. The drawing, the way that you're communicating today, you're still going to be giving the individual pieces of data for the instance over to whatever system. So you're not losing anything, I don't believe. Okay. Well, if there's any, if anybody has any additional questions or would like to actually get a demo, please contact Devin. And we have 4 more minutes.
Thanks, David. We'll probably wrap up here in a minute unless there's some more questions. And as I said, next month, Boundary Systems is going to present on a Friday. We don't have that topic yet, but we will announce it. This whole session is going to get recorded in the cloud, and I will post it onto our website and Facebook and LinkedIn group, and then I'll send it to TriStar, and they'll most likely convert it to their YouTube channel. So if you have any questions and you can't find it, email me, deborah.l.weich, W-E-I-C-H, @gmail.com. Thanks, everybody.
Thank you.
And there's one more question. I don't know if we can stay on just for one more.
Sure.
It's like from Chris Steele. You can see that.
Yeah. No, it's more than just the reduced CAD work, because the issue you have also is your other processes that are using those specifications. So when you're looking at getting the ability to more efficiently get the data into the ERP, when you're looking at the change process and all of the interactions of things that are involved in that change, there's a cost to doing that. So from the CAD perspective, there's some aspects that are good, but the overall is really to the business.
So if anybody wants to continue these discussions, like Dave had up on the slide before, just feel free to email me. I know we're wrapping up here, but some of these are larger topics that can stretch over many days and
Yeah.
right. So happy to facilitate those conversations if need be. So just wanted to throw that out there.
Thank you.
Thank you.
Okay.